Traditionally, we have Friday, we have seminars, continuing our seminars, and today is our fourth seminar with the topic of behavior-driven development. And mentor of today's will be Levan. So, Levan.
Hi, everyone. So it's not here at all. Today's topic is behavior-driven development. It was actually mentioned in one of the lectures. Does any one of you remember what is behavior-driven development? You can write answers in the chat, or you can speak with a microphone. So it's a software development process. So if you don't know, you can also write no, so that I know that you don't have any answers. Yeah, so behavior-driven development is a software development process. It's actually agile software development process that encourages collaboration between developers, testers, project managers, and business team. And let's compare it to like non-behavior driven test processes. So normally in the usual development process, we have business analysts, business teams, and usually the project owner who writes the specifications of how this software should look and how it should behave. After that, the specifications are sent to developers and testers. So developers write the software according to the specifications, and the testers write tests according to it. And in the end, when developers have like ready product, testers can check if it's behaves correctly. And after that, we also usually have some additional tests like acceptance testing to see like whether this product conforms to users' expectations. And one problem with this may be that there is not enough communication between various teams in this development project. So of course there is some questions from developers if something is not clear in the specification, but testers and developers are usually not part of writing the specification. And behavior-driven development addresses this. And in this approach, developers, testers, and business team, they write like expected scenarios together, and they write it in a special language, which is called Gherkin. It's British term for pickled cucumber, and actually it doesn't have any reason why it is named as such. So there was this guy who came up with this behavior-driven development, and his wife suggested to use this term for it. And this Gherkin, it is a language in which you write in like natural language, for example, English, or it can be a different language, but it has some specific structure so that it is easy to come up with tests from that, and it is easy for developers to understand how to convert the specifications to the program. And in this language, we usually write with this special format: given, when, and then. So given, for example, let's say we need to write a program for an ATM, so ATM machine. And for example, one of our scenarios can be like this: given the user has inserted the card in an ATM, when he enters a wrong PIN, they should get an error text or something like this. So in this case, given is some like prerequisites for this scenario, like to what state the system should be. When is some action from the user, and then we have this then part, which checks that like something happens or something doesn't happen. And it is in like written in natural language, so it can be written by like business team, but it is also very easy to come up with test cases based on this special language. And usually it is the business team who is writing the specifications, and then testers and developers are writing test cases and unit tests based on these scenarios. And what is a great advantage of it, and we'll also see that in practice, is that you have a like direct connection between this high-level specification, which the analyst wrote, and the implementation. So you can directly see when you run the tests, which parts of the specification were executed and which part is correct, for which part we don't have tests yet. And also this communication between testers and developers and analysts allows the program to be written from the start so that it is testable. Like often there's a problem that developers write some program which is really hard to test. And this can be a big risk for the project, because if testers cannot test the program, then like that's a big problem, because you don't know if it is working correctly. So thinking about that in advance has advantage of this program being easier to test. So this was a bit in theory, and now we can move to practical part. If you have any questions, of course, you can ask. And for behavior-driven development, we have several tools for several different languages. So the original program was called Cucumber. That is also why this language is called Gherkin. And we also have a Python library for that. We have a Python library for that, which is called Behave. And we will see how we can write some scenarios using this approach, and then how we can write some implementations. So if you don't have any questions, I'll proceed and share my screen, and we can look at Behave. So of course you are encouraged to follow this yourself. It will be pretty easy, I guess, and of course if I'll go too fast, you can always ask the questions and ask me to repeat anything. So let's first open the website for Behave. And let's head over to installation. It has usual installation steps. So I have Visual Studio open here. And let's create a new folder for our code. I'll create a new folder on desktop. Let's call it BDD for behavior-driven development. Now let's resize it a bit. Open terminal. And we can install Behave. Now I already have it installed, so it was pretty fast. So is everyone following? Okay, good.
I haven't downloaded yet. Can you?
Yeah, sure. I'll wait for it.
Sorry. Do I click behave on this web page?
So sorry, can you repeat the question?
Do I click behave to download? Well, on this web page of behave.
Oh no, you can install it with PIP. Just PIP install behave, and it will download it itself and install it.
Okay. Okay. Thanks.
Yeah, that's how we usually install packages in Python. So we have this package manager and package repository, which is called PyPy. And like this package repository hosts all the packages, and you usually just need to like specify install, and it will install it for you. Okay, so let's continue. Now this behave has its special organization of folders. We should have a folder called features, and this folder will contain our scenarios, both high-level scenarios and also implementations in Python. And as an example, we can imagine that we are testing Python or developing a Python interpreter, and we want to check that all Python features are working correctly. And one of the features in Python is lists. As I remember, Alex talked about that in one of the seminars. So let's, for example, list A. We create lists with square brackets, and it can contain some elements, numbers, or it can also be text. Like that. And Python also has this feature that if you want to check if list is empty or not, you can just, the one way would be to check its length. And you can see that its length is 3. So if its length is 0, then that's so it didn't print anything because it is not 0. And we have a more easy way to do it, to just write like that. If list A print true, else print false. So it just checks if the list is, if there is something in the list. And we call this kind of values like truthy and falsy. So if you convert it to a Boolean value, which is true or false, here we get true. if you put an empty list there, it is false. There are also some other false values, which is 0. And none is also false. So this is just a tool to like easily check if you like have something, or if it is empty, or if it is 0, or it is like nothing. So we can create a feature for that. And for these Gherkin codes, we have the special extension, that feature, and we can name something. For example, list feature. And first we should write name of the feature. So let's call it this, list comparisons, for example. And then inside this feature, we have some like possible scenarios of how it should behave. So let's create scenarios that, for example, empty lists should be falsy. And then, do you remember the special words in the Gherkin language? So you can write it. The special words with which we write the scenarios. So first is given. Given something. Okay, what do you mean with dash? Okay. So it was given, when, and then. So we can start with given. So given, we have an empty list. And in this case, we do not need when, because we do not do anything. We just continue with them. Given we have an empty list, then it should be falsy. And let's also write another scenario. Non-empty list should be choosy. So now here we can write, we can start with the same thing, and then we can add some element. So given we have an empty list, when we add an element, and it should be choosy. So that is always like high-level scenario. So this is what business team is writing for you. But of course, it is all also communicated with the developers and testers. And also the advantage with this approach is that this business team needs to think about all of the scenarios. And so they have a chance to better understand what they want, because sometimes they may have some like abstract ideas which when translated to like concrete implementation may not become as it was expected. So like writing it in this way gives this advantage that they also understand what they want better. So now we can create an implementation for that, which is tests that we can execute. For that, we create a folder called steps. And we create a Python file for it. For example, py. Let's select Python interpreter. Yeah, I need this one. So as you can see, I have many Python versions installed. In your case, it should be chosen as default. And then we import from behave, import star. And this star notation means that you import everything that you have there. And what we are actually importing is this ability to specify this given, when, and etc. Okay, let's also see the API in behave documentation. So as you can see, we're here. So we created a feature in features folder, and then in steps folder, we created a step. And after that, we also created a scenario. As you can see, you can also add some, you have some additional possibilities here. And after that, we can move to behave. Oh, it's actually like that. Yeah, so here we import it, and then we write the implementations for each step here. So let's we can split this window to see both of the files together, like that. And we start with this one. So given, and here we should write what we have here exactly. Given we have an empty list, and we should write an implementation for that. You can call this function anything. I will call it step implementation. And this function obtains a context argument. You can also see it here. So this context argument, it is provided by this behave library. And you can use this context to, for example, store some stuff there. Or you can also get some information from behave using this context. So in this case, we will just create an empty list. So our list is just an empty list, and we can save it in a context. Context.ourList equals our list. So let's save it. So undefined. Yeah, I think it wasn't able to import that. Yes, I don't know. It is giving us this error, but it should still work. So now let's create an implementation for this one. Then it should be falsy. So of course, if you don't understand anything or if you have some questions, feel free to write it. So now we stored our list in context, and this is the same context, so we can get it here like that. And we use assert here. So you write assert and then something that should be true. For example, assert that 6 is greater than 5, and this will be true. And we also want our lists. We want this to be falsy, so we can add not here. So if this was falsy, then not this will be true, and in the end, we will check that this part is true, so we check that this part is false. And yeah, actually, let's try to run it first, and then we can add the implementation for this one. Yeah, I don't know why it doesn't like this. So I remember we can just run behave. So yeah, so it said that we don't have implementation for this one and this one, but somehow also this one failed. Okay, let's also add this ones. Oh, now good thing about this one is that we already have an implementation for this, which is here. So we don't have to rewrite it for this next scenario. We already have that, so it will just reuse it. And we just need to add this tool. So we have this when here. When we add an element, and the way we add an element to a list is we use append method. Our list append, and we can append any element. Let's add 0. Now let's try it here. So we have our list is empty. Then we append something to it. And we can assert, and now it should be true. Yes. So if we check the inverse, then we get an error. Okay, so now we need the last step, which is for this one. Then it should be, let's see. Yeah, we just assert that it's true. Actually, we also have an extension for this Gherkin language. Try to install it. I think this one's better. And yeah, so with this extension, now we have a bit better view. So let's run behave. So now we have 2 scenarios passed, 5 steps passed. And we can see the results here. And like again, the advantage here is that all of it is very readable for non-technical participants, like business analysts. And they can clearly see what features are implemented, what features are working, and we have this clear connection between our implementations and what this business analysts wrote for us. So that's it for the first example. In Behave, we also have some additional really nice features which we can use. We can just look at it. Let's check the tutorial. Yes, for example, one of the nice features is that we can write some scenario once, but we can write it in a general way. So, for example, we have this thing, and after that we write some examples of the things, and it will basically run the same scenario multiple times for each thing. And this way we don't need to write this one like a lot of times, and we can also reuse the implementations for it. Also, we have a similar thing here where we can pass the table, but here it will be run once, and you can read this table in your code. So which is also a nice thing, because we often use tables, for example, in our project, and it is a nice thing to have here. So now, okay, so Akaki, now it says 0 features passed, 0 failed, 0 skipped. Did you do you have this correct folder structure, Akaki? Because it needs this special folders in order to find your features and your implementations. Did you add features like that? Because like from your output, it seems that it couldn't find any scenarios in your code. So we also have and I think it's an interesting homework. Right now we we just went through it in a general way without connecting it to our previous topics of simulator. So I think it will be interesting to try to combine this behavior-driven development approach with the simulator and try to check some simulator features using this approach. For example, you could check. You could also just copy one of the test cases in API folder, for example, one with a collision, and just rewrite it with this approach. So, for example, check some collisions, or what else do we have? Let's open the folder. Tests. Yeah, so you could basically take any of the tests and rewrite it using this way. And of course, you also need to write this high-level scenarios for it. So, do you have any questions? Akage, did you manage to? Yeah, sure. I'll look at it. Are steps and list feature in the same folder? So steps folder is in the same folder as the lists feature. I can say it like that. And you have this features folder in the main folder where you're situated. And you run behave just from here. Don't see it. So let's check your example. Okay, I think the problem in your case may be that you haven't followed the indentation. So for example, here we have this feature, and scenario is inside this feature. So it's part of this feature. Maybe you could try correcting that. And also this given is inside that. And also sometimes we also indent this one, but it's optional. Like this. So this one is the Gherkin language, and it is general language, so it is not specific to this implementation. So you also have similar libraries in other languages like Java or C#. We can actually see the original program was called Cucumber. Explore tools. Um, yeah, so there are some official. The one that we're using is like semi-official, and yeah, as you can see, basically we have implementations for almost all of the languages. Okay, it's still the same. Okay, let's continue this in Telegram. On the first site, it looks kind of correct. Have you saved all the files? And maybe you can send another screenshot after the correction. Okay, so I guess if no one has any additional questions, we can finish here. And about any problems with following this one, you can write in Telegram. So goodbye, everyone.